Okay, so in this discussion, I'm going to go over how to calculate R average and U average, which is something we haven't really addressed yet, and then how we can use that to calculate heating load and annual heat loss. And this will be used in your lab this week. Okay, so here's an example of a wall. Okay, and in the cross section here, you can see there's two cross sections. There's section A1 and section A2. And if you go from outside to inside, okay, here in this cross section A1, you have different layers. So remember, when we calculate R value, we add the R values of the different layers. So when we want, so the problem is that that's easy enough if there's just, you know, a certain number of layers and that's it. But if we have a wall, we have framing here, which has, if you take the cross section of this, that has a certain R value going through that stud, right? And then this has a different R value because instead of the stud in the middle, you have the insulation in the middle. So there's really two assemblies here, two surfaces. Okay, we have the framing right here, and we have the insulation. And you can actually calculate the average U value and the average R value of any number of surfaces that are together, right? So if I had framing and a window and a door and insulation and different insulation, so I could have as many surfaces as I want, and I can actually calculate, instead of calculating the heat loss through each of those, I can combine them into one U and one R and ultimately one U value, and then calculate the heat loss through the whole wall instead of doing individual parts of the wall. And that's what we're going to do here. And so we have these two surfaces. We have framing and we have insulation. Okay, so A1 is framing, A2 is insulation. And you can see here's from outside to inside. A1 right here, right? So we have the outside air film, the siding, bam, sheathing right on the outside. This is all your building construction comes in handy. Then we have insulation for A1, A2 we have insulation. Then we have drywall on the inside, and then we have an inside air layer, right? So outside air, siding, sheathing, insulation, our wallboard, right? So our drywall, and then inside air. Okay, so these are exactly the same, except this one has insulation, this one has wood, right? So you can see same, same, same. This is different, same, same. Okay, so all you need to do is find first, okay, this is step one, you'll do this in your lab this week. You find the R value of each of those. Okay, so the total R value of each surface. So you add all these up, your total R is 7.11 and 15.7. And I provide a link to the table so you can look these up, the R values of the different surfaces in the lab. Okay, so we have 7.11, 15.7. We know that R is 1 over U and U is 1 over R, so we divide 1 by 7.11, we get 1.41 for our U value for the framing, and then 0.0637 for the U value for the insulation. Okay, so hopefully that should be pretty easy, because that's just adding, and then you divide that by 1. Okay, so if you use your calculator, you'll see that 1 divided by 7.11 is 0.1411. Okay. Alright, so now we have the R value of this cross-section and the R value of this cross-section and the U factor of this and this cross-section. Okay, so now we have, if we want to calculate the heat loss through this whole wall, remember our heat loss equation uses U, right? So UA delta T or UA HDD, okay? So we're going to get one U value by combining these. Now, remember, you cannot add U values, okay? You cannot add, let me put that down, cannot add U's, right? You can't do it. All right, it'll give you the wrong answer every time. So what we need to do is we need to combine these. It's really technically a weighted average, okay, but here's how you can do it. And we're going to find U average. So U average, this looks more complicated than it is. We'll do an example here in a minute. It's really, there's two ways to do it. it's u, the u of 1 times the area of 1, plus the u of 2 times the area of 2, and so on, divided by the total area. So if I have a u of, let's go back to our equation here, we have 0.141 and 0.0637. So let's say this was, whatever, 25 square feet, and this was 75 square feet. Then we would have, right, so that would be u would be 141 times 0.141 times 25 plus 0.0637 times 75, and then you would divide that by 100 because that's the total area. Okay, so that's one way to do it. That's not the, you can do it that way if you want to. The way I always do it is a different way. You figure out the percentage of the wall that's covered by each surface. So it's given here that 25% of the wall is covered by framing. Okay, so this is just a little snippet of the wall. If you look at the whole wall, it's 25% framing. And then the insulated layer is 75%. Okay, so now we have a percentage, 25 and 75. And so you can do the percent times the u, right? So you can have u1 times the percent of area 1 plus u2 times percent area 2, and so on. So we're going to use this one. Okay, and then if we want to find the r from that, we invert the u. Okay, so let's do our example here. So again, we have these two surfaces, 25% for one of them, 75% for the other. And so go ahead and feel free to press pause and see if you can figure this out. So remember, our formula is, so it's going to be the u percent area 1 times u1 plus, in this case there's only two surfaces, so percent area 2 times u2. And that's it. Okay, so that's going to be it. So go ahead and press pause and figure that out and see if you come up with this answer. So u average, it's just 0.141 times 0.25. Okay, say 0.141 times 0.25 plus 0.0637 times 0.075. You get that, you just do that simple math and you get 0.083. So our u average is 0.083. And to get the r average, you invert that, so it's 1 divided by that, so it's 12.05. So you can see 12.05, you should stop and do a little gut check here, right? So 12.05, it's going to have to land between these two r values, right? It's going to have to be somewhere between those two. And it is, right? And so that's how you can find the u average and the r average. Now we have a u average, so now instead of saying how much heat is going through the framing and how much heat is going through the insulation, we can say, look, this is the u factor of the entire wall on average. And now we can use this u in our equations, okay? So now if we want to know the heat load and the seasonal heat load through that surface, okay, we have our UA delta T, which is our Q dot, right? So in BTUs per hour, this is a review. And then our seasonal is UA HDD times 24. So let's do the calculation. So now we have this assembly. We know that we have a U factor of 0.083. Okay, so we have a 50 foot by 20 foot wall. What's the heat loss if you have a base temperature of 65 and an outdoor temp of 32, right? So we have our UA delta T. So press pause and see if you can figure this out. Simple plug and play from here. U is 0.083. Our area is 50 feet times 20 feet. Our delta T is 65 minus 32. So our heat loss at that point, if it's 32 degrees outside, you're going to lose 2,739 BTUs per hour through that wall. And that's how that works. So now we're going to integrate design temperature into this. Okay, so let's assume this house is in Denver, Colorado. And everything's the same, right? 1,000 square feet, 0.083 U factor. What's the heating design temperature? And what's the heat loss at this temperature? Okay, so we can actually find the design temperature table. So I linked to it here. In your lab, I provide a design temperature table, but here I'm going to link it here. Okay, so here's my design temp table. I'm in Colorado, so I can find Colorado. We'll go to 13. Okay, zoom in a little bit. So here is Colorado. Where are we? Denver. There we go. So my design temperature, this is my 99% heating temperature. It's minus 2 degrees Fahrenheit. So remember, in my design temperature, that means that this is the 99%. So that means it's warmer than this, minus 2 degrees, 99% of the year. In other words, it's colder than that only 1% of the year. Okay, so that's my design temp. So now I can plug this in to my heat load equation and see how much heat I'm going to need to provide at the design temp. Okay, so we know it's minus 2, so we just plug that into our UA delta T. Everything's the same except the outdoor temperature is minus 2, and you get 5,561 BTUs per hour. And lastly, if we want to calculate the seasonal heat loss through this same surface, let's say Denver has about 5,800 HDD each year. So what's the annual heat loss through just this wall surface? And again, our equation is UA HDD times 24. Plug it in. So it's the old plug and chug. If you plug that all in, you got 0.083 times 50 times 20 times 5,800 times 24, and then that would be 11.55 MMBTU would be lost through that surface over the course of the entire year. Okay, so that's how you can use the U average equation. And again, you can do any number of surfaces. You can actually do a whole building and look at all the walls, all the windows, all the doors, the ceiling, the foundation, everything. Calculate a single U factor, and then calculate the heat loss through it at different design temperatures and at the annual heat loss. Okay, so that should be it. Should be enough to help you through your lab.